I'm William Lin from Wiwynn Corporation, and I'm with a mechanical background. So thank you here for listening to my presentation. And my topic is about designing data center hardware for environmental sustainability. So here's my agenda, and I think I'll divide it into 4 sections. So let's start with the introduction. So we know that server is built with software and hardware, and for this year, we know that there is a main topic is that for carbon neutral, and so we have been providing some efficient design, such as we have been studying for lots of like immersion cooling, sort of things like that, and so but today, since I'm mechanical, so I'll be focusing on a mechanical design for the sustainable server design. And so I'll be talking more about the chassis design for a server. And so Wiwynn, as a data center solution provider, we have been asked to provide lots of solutions to satisfy the requirement for our customers. So we know that we have to build a lot of we know that we have to build a lot of different configurations, such as like generation upgrade or various function. So for generation upgrade, such as like GPU and CPU version and different form factor, and for various function for server, it will be like such as computing or storage. So we have been dedicating to provide to build more customized design in order to satisfy the needs of our customers. So so what is it about new customized design? So we know that when we have to build more stuffs, during the manufacturing for new modules, we will have lots of material waste, such as cooling, liquid coolant, and some plastic metal cut-off parts. So these we will have lots of waste during the process of manufacturing, and after several years, when those parts are disused and they are scrapped, we will have lots of pollutions with those parts, such as coil pollutions, water pollution, or air pollutions. So we have been coming up with the innovation design for sustainability. And 2 of the key points to achieve sustainability are a durable design and a low-impact environment material. And these will be contained the below 3 items: reduce, reuse, and recycle. So how exactly do we approach a sustainable server design with these 3 items? So first, for reduce, we would like to reduce the material waste and the manufacturing needs for building servers. So if we can decrease the usage of material, we can reduce the waste. And if we can also decrease the needs for manufacturing new modules, we can reduce the conducted waste during the manufacturing process. And for reuse, we would like to standardize the design of the server. Like if we can have more common parts, we can share those common parts among different projects. And that will also lead us to reduce the new toolings for all the new products. And the last one, recycle. For plastic design and for EPE packaging, we would like to implement the PCR and PIR material into the virgin plastic. So with this mix, we can have more, the parts can have less carbon emissions. So in the last section, I'll be talking more details for the solutions. So for the innovation design, how exactly should we achieve the endurable design and low impact environmental material? So we came up with two solutions. The first one is standardize the building blocks for mechanical parts. And the second one is selecting the correct recycled material. And before jumping into the details, I would like to show the commonly used material for server design. So as you can see from this page, most of the material, we use like metal, plastic, foam, and rubber basically in our server design. These are the most common parts that are used in mechanical parts. And for metal and plastic, these two parts take up over 90% of the server material. And so like metal, we use it at the base chassis, the top cover, and lots of brackets. And for plastic, normally we use it for air duct, handle, and like mylar. And for foam, I'll be focusing on the packaging design since the volume of the packaging stands a lot of volume. It stands a big percentage of the server. So for metal, by standardizing the mechanical parts, we can leverage the building blocks among different systems. And for the plastic design and the EP packaging design, we will be implementing the PCR material and the PIR material in our plastic. So let's start with the metal. So we would like to standardize the universal chassis. So by increasing the amount of standardized parts in mechanic design, such as base chassis, the load case, and the front panel and the rear wall, we will have more common modules. So if we can have more common modules, we can reduce the production needs for the new modules. And also, it means that we can have more common parts, so we can reuse all these common parts among different projects. So here's an example. So if we are going to design a new motherboard and maybe a base chassis, we can define the fixing hole or T-pins on the motherboard or on the base chassis. So we define the location of these two items. And for the future new builds, if we can also follow the same location of the T-pins or the fixing holes, we will be able to share different motherboards in one project. And also, we can also share one motherboard in different projects. So for the plastic design, we have been implementing PCR material in our plastic design. And so PCR stands for post-consumer recycled material. And so from the wordings, we know that these materials are for consumer waste. So these are the recycled plastic that are discarded materials from household, commercial, industrial, and institutional facilities. So the percentage for mixing the PCR material and the virgin material will be an essential task for this one. It means that with more PCR material mixed with the virgin material, it means that the impurities will increase and it will lead to weaker strength. So besides the strength, it will also have different impacts, such as tensile, the cost, and the modeling shrinkage for plastic shooting. So we have been studying the correct percentage for mixing the PCR with the virgin material. So how much carbon dioxide emission can be reduced if we mix the PCR with the plastic? So for example, if we use NC50RT, it means that 50% of PCR material is mixed with the virgin plastic material. We can reduce about 40% of carbon dioxide emission. And with more PCR mix, it means that we can reduce more carbon dioxide, but the mechanical property will be impact. It means that even if we mix more, but maybe the strength, the tensile will be weaker for designing the plastic part, and it will have some impacts for the server design. And for the server packaging design, we have been implementing PIR material, which stands for the post-industrial recycled material. So for the EPER, so EPER commonly used in the packaging for server. It is used to make sure that the product is sent to our customer without any damage. And so what is PIR? So when waste foam scraps from recycled from factories, they will reproduce it into new plastic raw material. And then the percentage of for the PIR material is also important. So we have to mix the PIR material with the virgin plastic part. And the same as PCR, with more PIR mixed, the strength of the new EPE it will be. So it will also have the cost impact and the strength impact for mixing this part. And so if we use 20% of PIR mixed with the virgin plastic, we can reduce about 13% of carbon emissions. And of course, with more percentage of the PIR mixed, we can have more carbon emission reduced. But the same, we have been studying about these to came up with the recommended percentage for PCR and PIR, because we want to reach a balance between the quality of the server design and between and the carbon reduced. So I think it's really important that we use the correct percentage of PCR and PIR to build the mechanical plastic parts and the EPE packaging. So in the past few years, Wiwynn has been designing servers considering the sustainability. So in most of our projects, we have been there's 70% of mechanical parts that are leveraged among different projects and SKUs, including metal parts and plastic parts. And for using recycled material, over 90% of our products are using PCR material, and 100% of EPA are using the PIR material. Yeah. So that's all for my presentation today, and we welcome you to our booth if you have more items that you want to discuss with us. And I think that's all for today. Thank you.